Hi everyone, it's Rohit. Welcome back. Today we will be looking at another geometry problem from the 2013 Aime I, and this one's actually number 9. So let's take a look.
A paper equilateral triangle ABC has side length 12. The paper triangle is folded so that vertex A touches a point on side BC, a distance 9 from point B. The length of the line segment along which the triangle is folded can be written as m times the square root of p all over n, where m, n, and p are positive integers, m and n are relatively prime, and p is not divisible by the square of any prime. Find m plus n plus p.
Okay, so I've actually written down some of the givens here. Like, for example, we know that this is 9 because the point was folded over at, um, at a point on side BC that was 9 from point B. I've labeled that A prime. So this must be 3 because the side of the equilateral triangle is 12. And now what we're going to do is we're going to label some of the sides here. I'm going to call this length over here x. That means this length will be 12 minus x. Now, since this paper was folded over at this dotted line, we know that this red length right here is actually equal to this length over here. So this is also 12 minus x because it was reflected over the folded line. Similarly, for the other side, we are going to call this length right here y, and we're going to call this length 12 minus y because the side is 12 long. Now, by similar logic, since it was reflected over the folded line, this other red length is 12 minus y as well. So in fact, if you wanted to, you could make those marks on your diagram. Okay, so we want to find the length of the dotted line, and we can do that because we're going to be able to find what x and y are. And I'm just labeling here that this angle is 60 degrees because it's equal to angle A. Obviously because it was part of the folded, it was folded over so it was reflected, so the angle must be 60 degrees. That's simple enough. And okay, so we want to find what x and y are, so we can use law of cosines on this triangle to find the length of this folded line, right? So we can actually first use law of cosines on these two triangles here to solve for x. So let's do that right now. First we have that 12 minus x squared, the whole squared, equals x squared plus 9 squared, which is 81, minus 2 times 9x cosine 60, which is just 1/2. So we can simplify that further. This just becomes x squared plus 81 minus 9x equals this side. So let's expand. We can cross off both x squareds. So we get 144 minus 24x equals 81 minus 9x. So this becomes 15x equals 63, which means that x equals 21 over 5. Okay, now let's solve for y. Do this with the red pen. Again, it's a similar process. We're using law of cosines. Plus 3 squared, which is 9, minus 2 times 3y times cosine 60, which is also half. So simplify this, and it becomes y squared plus 9 minus 3y. So now let's expand. Cross off both y squareds, and this becomes 135 equals 21y. So y in this case equals, so that's 135 over 21, which is 45 over 7. Okay, so now we want to use law of cosines on this triangle. What we can actually do is replace these lengths with the actual values. So 12 minus y, that is 39 over 7. 12 minus x, this is 39 over 5. So now we can use law of cosines on this folded over triangle. So let's do that right now. So I've called the folded over line f squared. Now we can solve for f squared using the law of cosines, which is a squared plus b squared minus 2ab cosine c equals c squared. C squared in this case is the square of the folded over line. So we can do that. So we have 39 over 5 squared, that's the length of one of the sides, plus 39 over 7 squared minus 2 times 39 over 5 times 39 over 7 cosine 60. Cosine 60 and 2 cancel out. So we're left with 39 over 5 squared plus 39 over 7 squared minus 39 over 5 times 39 over 7. So I've just written that out like this. Now what we're actually going to do is put this under a common denominator, which is going to be 5 squared times 7 squared. So here, let's do the math here. So we get 39 squared times 7 squared plus 39 squared times 5 squared. That's the first part. And the second part is 39 squared times 35. So on top we have 39 squared plus times 7 squared plus 39 squared times 5 squared minus 39 squared times 5 times 7, which is 35. I've simplified that there. And this is all over 5 squared times 7 squared. Let's simplify this further. So we can put all the 39 squareds on one side, so that's like 39 squared plus 39 squared times 74 minus 39 squared times 35, so that's just 39 squared times 39. And this is all over 35. Now, we actually have to take the square root of this. So, when we take the square root of this, this should actually be squared. So, we get 39 squared times 39 over 35 squared. And when we simplify this, we can, 35 isn't squared anymore, neither is 39, so we get 39 root 39, because we have a cubed here. Well, the square just goes away, but this 39 stays inside the radicand, and then over 35. And our answer was supposed to be in this form: m root n over p, or m root p over n. So what we do is we just add up all these components, and that's just 39 plus 39 plus 35, and this equals 113, and that's our final answer. So not too hard for this number 9. The trick was to actually realize that you had the reflected lengths over the folded line, and then just keep using law of cosines, using algebraic manipulation and law of cosines to solve for length, and that would lead you to your answer here, which was 113. So again, like number 12, it's not very difficult. You can solve these geometry problems using simple techniques. All it requires is just a little bit of work. And I hope you guys enjoyed this video, and again, if you have any questions or comments, please feel free to use the comments section for that, and if you have any questions, I'll be more than happy to answer them for you.